Hi, my name is Paco Nathan, and it's a pleasure and honor to get to present here. I haven't been involved before in Toronto machine learning community and the Toronto Machine Learning Summit conference, although I was really looking forward to this. So thank you, David and Sahara and Tian and all for all of your help here. Um, the talk is about an NLP survey, uh, which we did recently, but it surfaced a lot of interesting issues, insights, discussions, contrasts that we're seeing about the broader scope of AI adoption in the industry. So I wanted to share some of these results here. By the way, if you want copies, I'm still uploading my slides. They will be available at this URL, and that should be set up within, probably by the time I've completed the talk, these slides will be available online, if not within the next couple of hours. So as background for this, I work very closely, my colleague Ben Lorick and I work together on a number of things, but one of the things we're doing is to conduct industry surveys and then summarize the results as published reports. And we do this periodically. We've been doing this for a few years now, trying to cover areas where we think that there might be some controversy or maybe some insights that could be gained. The methodology that we use is somewhat different than other surveys we've found so far. What we're trying to do is create a contrast study between organizations that are using machine learning or NLP or cloud or however, whatever technology area. We want to identify the practitioners that are really making effective use and they're finding return on investment and probe them to find out more about their practices, and at the same time compare that against companies that are just even getting started, so that we can do a contrast study between sort of the practitioners and the people who want to get into this. What's the difference? It's another way of saying really, the people who have already led the adoption in these fields, what have they learned and what have they really gained out of it? Hopefully so that other people coming into the field can benefit from those learnings. And so I've got links here for all of these reports. They're free downloads. Generally, we try to do about a 40-page report for each. And the most recent one was regarding natural language. So we conducted this over the summer, and this was being done in conjunction with a vendor. John Snow Labs had sponsored this because they were leading up to a conference called NLP Summit, which was held in early October. There's a free download. Ben Lorica leads a company called Gradient Flow, and they hosted the survey. So if you go to this URL, Gradient Flow 2020 NLP survey, that'll download the report. But I'd like to drill down into both some of what we've seen out of the report, the high level takes, as well as some of the feedback that we got from industry practitioners, sort of what did we have or not have in the report. And also just taking a look at the industry in general in terms of NLP. So, the intent of the survey was to see how technologies are rolling out in the industry, and it ran for about 41 days. We had respondents from 50 countries. And I want to shout out to a couple of our colleagues, Jen Webb and Kathy Yu, who really helped out on this. So we're looking at important contrasts. We're trying to understand the people who have at least some few years of history as NLP practitioners in the industry and deploying use cases in production versus people who are just getting started. We're also trying to draw a contrast between people who are in technical leadership roles, whether they're engineering managers or tech leads or however, architects, et cetera, but they're making decisions about adoption. And so, again, trying to draw the contrast between the technical leaders, decision makers, and the general respondents. And of course, we were also looking at things like geographic region, company size, sort of the scope in terms of the scale of documents you're working with, et cetera. And it turns out we got a pretty good sample. A quarter of the respondents were in technical leadership roles. That's actually higher than we would typically see. So that was good. We're able to at least get some contrast about the decision makers. But also, we really got a nice distribution between the practitioners versus people who are just getting started. So we broke this down into three areas. There are people who have been doing NLP in production for 5 years or more, versus people who are sort of mid-stage, they've got a few years in, versus people who are just getting started. And it's a pretty good breakdown between those. Now, I covered this in a lot of detail at the NLP Summit. I gave the opening keynote, which really explored, step by step, all of the different areas. So if you want to go through that in gory detail, I certainly didn't want to rehash that. I wanted to provide something new and extra value here for a Toronto Machine Learning Summit. But all the slides and the video of it, they're all online. Also, Ben Lorik and I did a community Q&A session. It's a new thing called Kindred. Some of our colleagues in San Francisco created. It's kind of like Discord, but they actually came out of the background of doing smart contracts and decentralized systems. So Kindred's kind of interesting. Actually, it's quite interesting. But we did a really interesting Q&A there with a lot of people asking questions, trying to field, really, in addition to what questions we pose to the industry, what are the typical kinds of questions? And as well, I've been working in NLP for a long time. Just as far as my background goes, I made the mistake, allegedly, of studying artificial intelligence in graduate school at Stanford in the early to mid 80s. And at the time I was told that there's really no hope. I mean, don't even bother. And then I went further down the rabbit hole. I spent 7 years doing research and development work in what was at the time a relatively obscure field called neural networks, including some hardware accelerator projects, one of which was based in Vancouver. So I used to live in BC. I have a lot of family from Nova Scotia. I was born in the US, but I try to be an honorary Canadian. Anyway, long story short, I've been doing NLP work for a long time. And I invited some friends who are really excellent practitioners. Amy Heineke at Primer AI, doing a lot of work in natural language, understanding natural language generation. Joel Gruss, who led Allen NLP, he's now at a different company, but he'd done a lot of work on some of the research tools in NLP that were really groundbreaking. Danny Viesro is my colleague from Recogni. I'm one of the advisors there, and we'll show a little bit of what they're doing. Also, Felicia Lecou, who'd been in UK Gov working on NLP and knowledge graph applications. She's now at Adarga, also in UK. But there's a really interesting panel discussion. There's the video available. We tried to bring up some of the points from the survey results, but then get their feedback as practitioners out in the field. What are they seeing? And also as people who are leading open source projects. And so, it gives a real pragmatic view of NLP, annotation, lots of annotation, and how that feeds into use cases downstream. Definitely touched on the importance of human in the loop approaches, which are crucial in most of the applications of scale that I've ever seen. And also an interesting thing we found was, to the extent that we're doing a lot of annotation and classifier work, that leads into how organizations consume NLP applications. And an interesting thing that most of us had encountered was where executives in a company would actually veto our work kind of at the last minute, saying, actually, you're touching on this idea of using AI and having shared definitions across organization. And as executives, we're not sure we actually like that, because we'd like to be able to change those definitions at our discretion. So there's sort of this okay boomer moment in AI that actually we're seeing from a lot of sectors. The Davos conference talked about this in 2019, where there's sort of an age group of executives that are somewhat threatened by AI, and it's kind of a generational thing. But we're definitely seeing that in NLP as well. So some highlights that I think are really important to understand. One of these is that budgets are growing, and we're seeing this reported amongst the organizations who have been working and seeing return on investment for a while in NLP, and also amongst the people who are more the practitioners. You see this contrast. Those who have been in the field and seeing return on it are investing more. And so, I'm breaking it down. 53% have at least 10% bump in their NLP budget. 31% we're seeing a third higher. And definitely, even in the large firms, we're seeing kind of an echo of this in enterprise. And this is consistent with some of what we've reported over the past few years of AI adoption trends in general. We were actually quite startled last year when we saw that early in 2019, people were reporting that 43% of the people who come from mature practices were reporting that more than 20% of their total IT budget was being invested into AI. Whereas the people who aren't even getting started aren't investing anything. So you see this real gap between sort of haves and have-nots, that the firms that have return on investment in AI are doubling down on reinvestment. But yet, from this and other survey work, as well as correlated studies from MIT Sloan and McKinsey Global Institute, Michael Chewy in particular, we're seeing that more than half of enterprise are years away from the digital transformations which are prerequisite before they can even start to become competitive in AI use cases. So you see this gap, and if you're familiar with sort of the curves for diffusion of innovation and this notion of crossing the chasm, we're actually seeing the chasm shift over. Usually, Jeffrey Moore and others have talked about the chasm being between the innovators and early adopters versus everyone else. And what we're seeing now is instead there's the chasm that's emerging between innovators, early adopters, early majority, and everyone else. So it's almost like a 50-50 split. And in a post-pandemic world, unfortunately, this gap between haves and have-nots accelerates even more. We're seeing a lot more investment in AI, obviously with people working remotely and with all the change on logistics and a lot of uncertainty. There's a lot of use cases for machine learning, knowledge graph, et cetera. And the other thing to mention about this, of course, is that the cloud providers appear to have a first mover advantage with respect to this business phenomena, if you will. We'll explore that in a little more detail in a few minutes. Now, as far as use cases, this is where we had some surprises. We wanted to try to drill down on where are people working in different areas of NLP. And one of the surprises was when we look at the top 4 most popular applications, definitely document classifiers. Of course, this is enormous, and it cuts across a lot of different verticals. Whether you're working in pharma or insurance or finance or wherever, you're probably doing some document classification. That's just a given. Named entity resolution, and with it, more advanced areas such as entity linking, of course, have become much more pronounced now, with deep learning tools being able to augment those and get a lot better performance. Sentiment analysis is still up there, but it seems to be ebbing a bit. I wouldn't say, when we've done polls or surveys before, there was more of a cohort of sentiment analysis. And I think that is kind of starting to dip. But the thing that was a surprise was knowledge graph. And that's now in the top 4, using NLP to support knowledge graph, obviously developing annotations that feed into some sort of knowledge engineering, knowledge-based work. And also, I should mention that, particularly with respect to healthcare, we see a lot of use cases in terms of de-identification, and there has been a lot of interesting work in de-identification using machine learning for that. So that's kind of how the use cases break down. As far as the popular libraries, it was interesting. Spark NLP came out. 1/3 of the users were using Spark NLP. 1/4 of the users were using Spacy. And then 1/2 of the users represented using either or both of Spark NLP or Spacy. And just for what it's worth, I'm a lead committer for a project that's based on Spacy pipelines. So I also, for what it's worth, I used to be the community evangelist for Apache Spark. So I kind of have a foot in both camps there. Definitely, there's a lot of work with Allen NLP. They were a bit surprised because they think of Allen NLP as a research tool, but yet there's production use cases. Of course, NLTK has been around forever. It's kind of old and clunky, but especially in finance, there's a lot of older, almost legacy applications, I think, that probably still have that. And Stanford Core, pretty big. GenSim has been around for a long time. Hugging Face is really moving up, Raza and others. I want to call out one that was not on our list, but I do a lot of work. I'd mentioned Daniel Villasuero earlier in our panel discussion. And full disclosure, I am an advisor for this company, but there's a really interesting open source project called Biome. And it's an integration of Allen NLP, PyTorch, Hugging Face, ML flow, weights and biases, and Ray Tune for the AutoML aspects of it. So, and also there's some newer things like checklists that are going in. We'll talk about that in a bit. But if you're looking for a really industrial strength workflow open source tool for NLP, Biome is handling a lot of integrations of these other really popular libraries. And they've had some large, in Europe, some very large use cases. I'm not allowed to say which, but there's a very large aircraft manufacturer in Europe, which they've done some work with this. And also, I'll just put in a plug. I'm lead committer for PyTextRank, and we've had a lot of adoption. We cut over a few years ago, actually a couple of years ago, to using Python. We'd been Java-based and Scala-based before, but we cut over using Python, got a lot of uptick, and then over the past couple of years, actually, I think it was about a year ago, I was sitting on a beach in Galicia, in A Coruña in Spain, and I got the idea from a grad student in one of my lectures, that I could rewrite this whole thing and make it a spacey pipeline. So, that happened in about 3 hours, sitting on the beach. So this is now part of the pipelines in spacey universe, and we are using spacey 2x now, and we're working on a new PR for spacey 3x. Okay, so let me dig into some issues, which I think are hopefully will prompt some discussion. Definitely had a lot of discussion about this. I was giving a keynote in Madrid on Monday at Big Things and talked about some of these aspects. I think it could be interesting for a lot of discussion. One of the things is, of course, we've seen this renaissance of natural language work over the past, well, let's just say 5 years. There's been an incredible amount of change. Spacey coming into the field with an opinionated AI that was based on Python really changed things, and it really opened up just having a lot more people with data science backgrounds of taking advantage of NLP, and also just more adoption of cloud led to a lot more of compute resources, because some NLP kinds of tasks can be very compute intensive. Short story, I was one of the guinea pigs when Amazon AWS first launched. I was one of the first few people to sign up and use it. And our team ran into some workflow bottlenecks doing NLP workflows on AWS in 2006. And so one of our engineers suggested a new open source project that had just been released. And we started adopting it for running our workflows. That was called Hadoop. And then there was a Jira ticket where Hadoop wasn't running efficiently. The I/O had some bottlenecks running on EC2. So, I wrote a check for $3,000 to have Tom White, this young consultant, fix the Jira ticket and commit a change so that Hadoop would run efficiently in the cloud. So this idea of like NLP consuming a lot of resources and needing to have cloud, it's been around for a while. Our application became the largest Hadoop instance in the cloud in 2008, and we were a case study for what became Elastic MapReduce. So I've seen this growing, and now, of course, we're at this point where all of the cloud vendors have very sophisticated services addressing NLP needs. You've got Azure Text Analytics, you've got the Google Cloud Natural Language API, you've got AWS Comprehend, and others. So some really interesting things there. And when we look amongst the practitioners and the more experienced people in this field, we're seeing about 2/3 are using cloud services. So there's definitely a healthy amount of adoption. And we try to break it down there amongst the different sectors. Definitely more of the technology companies tend to use this, whereas healthcare, not quite as much. There are definitely some issues there. And speaking of those issues, we wanted to find out, what are the problems? What's being reported is, frankly, it's expensive. Using the cloud services as opposed to using some open source on, your own use cases turns out to be very expensive. And the pricing models for the NLP cloud services seem to be somewhat upside down with respect to how people actually use them. There's also a matter of functionality and accuracy that we'll drill down into. And certainly, if you're talking about healthcare or finance, some of these areas, there's just really not a feeling enough comfort yet in terms of privacy for moving everything into the cloud. So we want to drill into that, and one of the big problems is accuracy. And we'll talk about this. Accuracy is a very loaded term. It's a very large word. It means a lot of things. But people are reporting that they have problems with accuracy. So AWS Comprehend, for instance, we're seeing where just so many people say it's not accurate enough, and there are reasons for that. And also Azure Text Analytics, similarly cost. We're seeing this kind of across the board, accuracy and cost. So, the problem is that these services get more expensive as your collection of documents grow. And, typical ways you'll go in and use the services and you'll try them out and show proof of concept, and then you start to scale up. But as you're scaling up, you find that your bill goes up disproportionately. So, that's one thing that really hits people. There could probably be more creative ways to do some pricing on that. And the other thing that I've run into personally, and I've actually been in a case where I was partnering with, talking with people who are product leads at Google, at Amazon, even at Microsoft, and at the conferences backstage, talking with them as they're going out to do their keynote. And we ran into these problems that they don't really have a lot of means for customizing models. And part of the problem is that when you're working in natural language applications, so much of what you do is domain specific. And so much of what you have to do is to tune your models and customizing them, changing the lexicons. So, when these cloud services sort of try to do a one-size-fits-all offering, and they don't allow means of customizing, particularly when it comes to changing the lexicon, the vocabulary, where the services just aren't very good at recognizing terms of art, it's sort of just throwing out the entire value prop. I had a especially painful thing where I was doing technology conferences and we wanted to create transcripts, and we were working directly with the product team at Google. And every time somebody would say Docker or Kubernetes, the thing would translate as doctor or Cooper Nettles. Just ridiculous. And we're like, can we change this in any way? And the short answer was, no, it's not our priority. So, this brings us to an interesting thing to try to understand what are the business drivers for NLP adoption currently. And I think this is important as a data scientist. What can you see as a really clear value proposition for the business people in your organization? And so what we're seeing is that the breadth of NLP applications tends to grow as accuracy increases, particularly for use cases that must be able to do natural language understanding or natural language generation. And also, an important thing is that in NLP, we're not talking about automating as in replacing existing business processes or replacing people. We're talking about, by and large, augmenting. And so you really have to look from a business perspective and say, how can I have enough accuracy in my NLP apps to augment my existing business workflows, but also have them be cost effective as they scale? So unless you have those two things, you don't gain more breadth. And this is really critical. And we find that the open source people get this, whereas some of the cloud AI services, I think, could stand to learn from this. Now, there's a caveat that when we talk about optimizing machine learning models, this comes from one of my AutoML talks, but when you talk about optimizing an ML model, gosh, what does that mean? Because I can tell you from an ML practitioner perspective, I can think of dozens of ways, dozens of different parameters for optimizing. I sort of put enough that would fit on the screen here. But in terms of accuracy from like a theoretical perspective of NLP, or machine learning in general, I can talk about precision, recall, specificity, perplexity. And then when you get into NLP, you can also talk about more of this domain-specific aspects of that. So accuracy actually means a lot of things. And it really does come down to, does it fit our use case? Okay, so extensibility is really where this could be solved. We hope to see more of this in the future. And I've covered most of this, so I'm going to move ahead. Scalability is also an issue because, in NLP, you're typically working with a document as a unit of work, as opposed to something like log files that you can slice and dice and parallelize in a lot of ways. Deep learning has also increased the complexity with this a bit. So scalability is kind of a hard thing. Now, we are seeing some tools that add a lot of engineering rigor into NLP apps. I think that Marco Ribeiro and company who just did Checklist, did the Beyond Accuracy paper. If you haven't seen that, it's a really fantastic thing. Being able to do behavioral testing, sort of black box testing in QA with NLP. And I think it's a really great step forward in terms of engineering rigor. Also, the Raza folks, Alan Nickel and company, they've done CDD, which is conversation-driven development. And I'll definitely reference a lot of great work out of Pandora Box if you're working in chatbots. There's a great interview here with Lauren Kunze working on, they've got 10 years worth of baseline development with chatbots. Okay, and let me shift gears a bit and drill down on some of the cloud problems. So you may have heard, but since late 2017, there's sort of been this arms race, starting with Allen NLP, followed up by Google and Microsoft and others, Alibaba. And essentially, the cloud giants have been doing this thing where at one point, they were actually publishing papers every 2 to 3 weeks just to one-up each other. Like, I got a 1% point better than you in accuracy. So you get these enormous models that might take 3 weeks to train on a huge cloud instance. And they're just scrambling over each other with this kind of arms race to have ever larger models. So, we joke about it as Sesame Street because the names were like Elmo, Bert, Ernie, etc. But it's been very sophisticated models, and I try to break down some of where the technology development has been in these. The idea is really to look at embeddings and using deep learning with language embedding. We can talk about that in more detail, but essentially it's very good at understanding sequences of things or predicting what should come next in a sequence of things. And it leads toward very large models. There's been this hypergrowth of parameters to the point where some of the latest ones have hundreds of billions of parameters. Really insane. And you look at the carbon footprint on these, and for instance, training BERT with neural architecture search, there was a paper that came out that showed that training one machine learning model would have the carbon footprint of running the average gasoline automobiles, 5 of them for their entire lifetime. And there's a great, somebody who can speak to this much better than I can is Neil Thompson at MIT, talking about the computational limits of deep learning. Essentially, we are seeing some decreased marginal returns if we just go down this road of having larger and larger models based on larger and larger data. And there's climate implications. Really fantastic work. There's a great one-pager where he does a synopsis of his research. Highly recommend. So the cloud providers kind of have this dilemma, and they're going down this route of bigger and bigger and bigger, and then providing SaaS services, and it doesn't really quite fit. Now, I drew a contrast recently. There's an excellent podcast from Malcolm Gladwell, from I believe from Toronto area, if I recall correctly. He did a review of the Anderson and Sally book, The Numbers Game, and it's this contrast that American football is based off of hiring superstar players. They can score points from halfway across the court. European football, in contrast, you require full team coordination just to reach every goal. And so there's this real different sense of how do you invest in building teams, whether you're playing American basketball versus European football. And the cloud giants are playing a game. You look across the board, they've locked up the AI talent aggressively. They own enormous data sets. I've seen Jeff Dean talk about the first point. I've seen Andrew Ng talk about the second point. Is very deliberate. They own the public clouds. And so it's prohibitively expensive for somebody else to recreate their research. But yet at the same time, we're seeing these like really high customer dissatisfaction rates on their NLP services. And the fact is, one size fits all just really doesn't work as a strategy. And these enormous machine learning models, they have diminishing returns. So the idea of investing in sort of superstar AI services, it's a ruse. And it creates this real tension between what we're seeing in the SaaS business offerings versus how open source approaches in NLP are addressing the long tail of NLP use cases. So moving forward, I know I'm almost out of time. I'll reference a talk from Uli Sadler from U Manchester. We were in a track together last week. Really excellent work on this idea of leveraging both data-driven machine learning models with domain expertise represented in terms of more ontological approaches, knowledge graph. And Graph AI is leveraging this. There's a really great talk from Mayank Kejriwal at USC about using knowledge as an abstraction layer and leveraging knowledge graphs, even on top of traditional data analytics, if you will. I'm involved in a few different conferences about knowledge graph. I definitely invite you toward this. A lot of great work in this area. And also looking ahead, if you're interested in NLP, the one resource that I highly recommend is NLP Progress from Sebastian Ruder. There are updates almost every week, and it has leaderboards that contain both what's the latest research as far as what are the data sets and the code to reproduce it. Also, another area that's really interesting is the applications of responsible AI with respect to NLP, and we've got a forum about that coming up on December 15th. If you want to get a hold of me, here's a link. I'll make my slides available, and I'm out of time, so let me cut back over into Q&A. Thank you. Okay, great. A lot of questions. Let me scroll up. Oh, okay. So first off, thank you very much for the questions here. And now I apologize. I wasn't able to see the chat Q&A before while I was speaking. I was in full screen. Tzvizia, you had a point. Yeah, you couldn't read the fonts in the graphs. Some of those graphs that I referenced, they were copied out of papers and whatnot, but they're linked to the primary sources. So they're a little bit difficult to see on the slides, but hopefully if you follow the links, one of the problems is when I do talks, I typically have a lot of slides that have a lot of primary sources linked. I have people coming back to me 3 weeks after a talk saying, hey, I finally got through all the slides. So hopefully I have been diligent and linked out to everything there. And you'll be able to see these things in situ at full scale. Sonia, when people say they use NER, when do they use entity linking along with that, and when do they not? Is there information about this in the survey results? Really great question. We didn't drill down on that in the survey. We didn't have that level of granularity in the questions, although for a follow-up, that would be one of them I would be asking. Named entity resolution is something that's been around in the NLP packages for a while. Entity linking is somewhat newer. And so there may be kind of a semantic difference between them, but I do find that the libraries that do NER, it's a little bit older approach, and it's a little bit more static, if you will. You have to pre-train in different ways. I find the results are, whereas it's popular, it's maybe not the best results. Entity linking is something where you'd be leveraging a graph, and so you can have this sort of adjunct knowledge graph that augments your NLP work in very intelligent ways. And you'd be doing graph search, and maybe perhaps even be looking at things like link prediction, maybe using some of the more sort of hybrid approaches between, say, deep learning and probabilistic methods on graphs. So entity linking and NER, I would say there's a split between them. It's not in the survey, but I can follow up with some of the information about that from some papers. I noticed, Dave, thank you for referencing some of my background there. That Wikipedia page on me is just horrible. There's a guy in Italy that has had a lot of fun editing it. He actually added himself as like a contributor on some projects where he was never around. So it has very little to do with me, but if you do want to get a hold of some material, here, let me link in. I've got a lot of other background material at this URL. And the Wikipedia page for me is really bad. Great, thank you. Okay, in the list, Darius had a question, is the list in descending order of the number of applications of popularity? Not exactly. The list was in order of how we had pulled it, so we try to preserve that. But then later, we do have the numbers there. And if you look at the report, we have more detail about the numbers. Let's see, interesting. Okay, Walter Wu thought the conversational use case could be on the list, especially the spread of chatbot, smartbot. Yeah, we were thinking too. I mean, I've been involved in the O'Reilly technology conferences for a number of years. My colleague Ben Lorica led the AI and data science parts of it for 10 years. Sadly, that business is no more. It was closed earlier this year. Although Gradient Flow and others are kind of picking it up. So I've been out there in these technology conferences, and yes, there's a lot of conversational AI, hosting so many interesting talks about that. we did not see that quite as strongly in this year's survey. So I do believe, also from other work that I'm doing, I certainly believe that knowledge graph work is really pervasive, although somewhat private when you go into industry. And we're seeing that definitely on the rise. Whereas I think the chatbots, they had a big bump, and a few years ago it was super popular. I would go to investor dinners and like everybody's doing a chatbot company. These days, yeah, I think there's a glut. I think there's too many. There are some really great services. Pandora bots and Raza, I've mentioned, really excellent. But there's a lot of little ones that are kind of iffy. So I do think that, yeah, voice is deceptively hard to do well. And I do believe that the cloud vendors have over-indexed on the chat applications a bit too much, especially for their services, just to sort of generalize toward those. Whereas I believe that there's a breadth of NLP applications that have nothing to do with voice. So that remains to be seen, but really good question. So Mia, follow up what you asked. Okay, how many of the respondents use multiple NLP tasks in their projects? Yeah, that's a really great thing. So this question speaks to the notion of pipelines, that typically when we build apps, they're in multiple stages. And if you read the slides, I kind of had to gloss over certain parts for the sake of time. But one of the problems with understanding things like accuracy in NLP is the fact that even the NLP libraries, if you're just using something off the shelf, they're typically arranged in stages. And there are models at every stage almost. And those are trained in different ways. So when you look at like the accuracy of the end results, you have to understand that there can be some errors or bias or whatever that are being introduced at every stage of the workflow. And it's really interesting to try to understand the use cases of like, where are they using multiple kinds of tasks, or where are they customizing these? So for instance, Mia asked about text classification, NER, machine translation, etc. Yeah, you really have to mix and match per use case. This is not something that we did specifically in this survey, although I think for a follow-up that would be brilliant. Cyril, okay, interesting results. Curious about the survey part. What mechanism to use to ensure the sample is representative? It would be nice. I mean, yeah, great question, Cyril. It's difficult. I've been involved in a number of surveys. Just getting a good sample is hard. And then, how do you ensure that the sample of results is representative? It's difficult because you kind of have to scattershot out there. Just, in this one here, we had respondents, like I say, from 50 different countries. I've been involved in surveys where, frankly, the first time that Ben and I did this, it was supposed to go out to 300 people as a follow-up to an event. And somebody in marketing made a mistake and sent out to a list where there were 80,000 people on it. So we ended up getting tens of thousands of responses. And we're like, hey, big data science. Yeah, we've heard about that. Let's do some analysis. So, trying to do controls on this is much more difficult. Trying to do panels or anything like that, very set survey methodologies, is difficult. So, do take it with a grain of salt. This is probabilistic stochastic in nature because we are basically throwing it out there. And it's all self-reported, right? We're not doing follow-ups to make sure that somebody indeed is a vice president of engineering. So, but we do get, again, probabilistically fairly good results. Also, great question from Somia about how many respondents work on non-English NLP. Yeah, this is great. And I've been involved in definitely different areas of different languages. A lot of how I came into this was working in special languages at Stanford, where I was studying Arabic and Farsi and Spanish and French, and eventually Russian and Japanese and a few others. Welsh is the latest. A lot of what's reported is about English results in NLP, but there's a lot of great resources in non-English. And frankly, when I teach courses in NLP, this is the most common question. When Ben and I did the community Q&A about this survey, that was one of the top questions, was just where can I get a hold of great resources for non-English NLP? And there are a lot. I mean, if you're looking at sort of the trained models, Spacey is really great in terms of having a lot of support and also being extensible. Spark NLP, Stanford Core, and others are very good about multi-language support. Certainly, if you're using other assets like the knowledge-based kind of assets like WordNet or some sort of thesaurus, there's a lot of those in multiple languages that are out, whether you are talking in a variety of languages. And it's difficult. I mean, some languages, like for instance, I've studied, Alokatarabia, where you have the connections between letters. It's much more difficult to say segment from handwritten text. Some languages are easier to handle with computational linguistics than others, but there's a lot of good resources, and we can talk about that offline. Let me scroll along. Do you see emerging tools, techniques for integrating the search part of AI with deep learning models? From Jeff Hendrickson. Fantastic question. And I know some people are having a lead. Now, I'll stay in here as long as people want to talk, really. Great question, Jeff. Yes, actually, this area of integrating search, or rather, going towards search and discovery and integrating NLP along with what can we do with deep learning, along with what can we do with graphs. Yeah, this is really taking off. And when I mentioned knowledge graph, a lot of the applications are for discovery, content discovery. So, case in point, if you are working at a large manufacturing company and they have a patent portfolio, which they do, and then they have, these different operations, production operations. What is the graph going between the patents and the research and what's going on in production? And then how does that extend out into the suppliers, the supply chain, if you will, going out into customer use cases? So, a lot of that begs really great tools for search just to understand what's going on in your company and how can you jump in and try to resolve a problem. And so that's where we see a lot of this work in NLP leads toward annotation. Annotation leads toward knowledge engineering, and that leads toward typically some type of tooling in discovery and search. A really great example of this that I would point to is I'm involved in Metadata Day, which will be announced soon. It'll be on December 14th. LinkedIn is hosting it. So a lot of the sort of the AI native companies like Uber, Lyft, Netflix, Airbnb, Stitch Fix, LinkedIn included, although they're now Microsoft. Their response to GDPR was to have internal knowledge graph projects and start getting busy on understanding their data sets and how they're linked and how they link out to use cases. And then once they did, they found out that the data science teams had much better productivity because the metadata was available at a quick search. And so you see people like Mark Grover, from Toronto, who led that project at Lyft, and now it's spun out into a new company. It's the Adminson open source project, and you see others. So we're actually having a conference, a one-day sort of mini conference amongst the different open source projects from those AI teams that were doing exactly that, using these kind of tools for search and discovery. Initially for sake of compliance, but then later on they found there's business upside, and we'll be doing that on December 14th. And I've got a link to it in my slides. Okay, sorry, I know I'm long-winded on some of these. Let's see here. Any thought on the AI platform, Kubeflow, MLflow? Yeah, there's a lot of adoption. There's a lot of questions about that. If you go back, there was a slide I mentioned about Biome, and Biome is actually doing a nice integration of MLflow along with weights and biases, along with Raytune, so that you can be running experiments and then getting a lot of good feedback and measuring these. And yeah, you do see a lot of adoption. The thing about these is that none of these really handle the entire thing. It's not one size fits all. So you kind of need to mix and match. And so that's where tools that do really effective integration are good. Kubeflow, I'm probably not going to say too much about Kubeflow. I definitely have friends who work on that and who have worked on it in the past. And they're definitely trying this, although it's kind of large and it's a bit difficult to learn. But definitely these kinds of tooling I think are very important if you want to get into the production aspects of NLP. Great. Yes, please follow up online. So Mia, thank you very much. Yeah, please link up with me on LinkedIn. Catch me on Twitter. I do office hours every month with the Knowledge Graph conference community. And in fact, tomorrow morning I'm doing office hours. So if you check on my site, those are published, and we try to put those on LinkedIn and Twitter. Jeff Henriksen, elaborating on the examples you're thinking of, what do you see as emerging tools and techniques for integrating the search parts of AI with deep learning models? Semantic web, MCTS, logic programming, probabilistic programming, etc. Yeah, no, Jeff, that is fantastic. I mean, I would love to actually do another talk follow-up about that, because we've recently launched a new project called KG Lab. There, in the Python community, in terms of data science, there's a lot of great tooling and a lot of stuff we use, whether you're talking about pandas or scikit-learn or Spark and all this stuff, right? And with respect to graphs and semantic technologies, there's some real popular ones like RDFlib, and you can get into some other areas. There's Scosify, there's PyViz, there's NetworkX. There's a lot of things, but they're all kind of balkanized, right? They don't really fit together. When you look at things like NumPy and Pandas, there's really good integration. You can use them for a lot of things. But when you get out into the areas of some of this area of AI, of leveraging some of the semantic technologies, and then trying to integrate them with deep learning, the stuff just doesn't fit together. And so we started a project to be able to have more of an abstraction layer to make all these parts fit together. So initially integrating RDFlib, NetworkX, PyViz, and a few others. And now we're building it out to include Ray for doing more scale out, and doing like a Parquet file format as a new kind of graph serialization. So yeah, I'm definitely involved very much. Also PyTorch integration to be able to do the deep learning parts of like the embedding. And your point there, yes, we're definitely leveraging a lot of the semantic web technologies, reusing the controlled vocabularies and a lot of the metadata for type checking, if you will, with the IRIs. And you mentioned about probabilistic programming and logic programming. Certainly, an interesting thing is that whenever you talk about deep learning, a lot of it is just sort of creative overfitting, right? Because deep learning, you have these enormous spaces of a lot of potential parameters. I've done neural networks, like I say, for almost 40 years. And the conceit there is that if we're very careful about overfitting and do it creatively, we can come up with miraculous models. And we just chew up a lot of carbon, right? The thing is, though, that once you've got a deep learning model trained and you start to understand it well, realistically, it's probably a hidden Markov model. And if you want to go for a closed form analytic solution, most of these graph-based models are one way or another, they're Markov. They reduce down to Markov logic and statistical relational learning one way or another. So you see things like probabilistic, soft logic, Markov logic networks, tractable Markov logic. Yeah, and there's some really great people, Lisa Couture at Santa Cruz and Pedro Domingos at Washington. See a lot of really interesting people working on interesting projects. And I believe that is a lot of the future. Right now, that's still kind of at early stages and it's very computationally intensive. But when you can start to describe graphs in terms of sort of the structure semantically of what you expect, and then you start to populate them, or as we say, ground them with atoms of actual data instances, leveraging from the data. And then you can use that to sort of focus a lens on different parts of the graph and use that as your training examples in deep learning. You can start to leverage both of them. And then you can start to go a step further with some of the probabilistic graph aspects of being able to do link prediction, of sort of saying, let's abstract out what are the inference rules. If I were to take this deep learning model and now come back and say, can I distill it down into a set of rules to apply? That is extremely compelling because that gets through a lot of problems with fairness and bias, or at least leads to better solutions. That gets around a lot of problems with compliance and audits. And just in general, in computer science, we like to be able to work empirically with a lot of data, but then move toward more analytic solutions. So yeah, I think that's the billion-dollar question that you've asked there, Jeff, is you were probably asking more about the search aspects of it, but the long answer is, if you go back into, I was in grad school in AI in the 80s when hard AI was not about machine learning. It was mostly about, most of the hard problems that we foresee come down to search. And so you have A star and B star and all these search algorithms. And there's really no coincidence that Google emerged, actually both Yahoo and Google emerged out of Stanford, but specifically that AI program that was so focused on search in the early 80s, in the late 80s and the 90s, then produce things like Google. Because if you can do search correctly, then you can do a lot of other interesting AI parts. So yeah, alpha and beta, good, glad you mentioned that. Okay, we could talk much more. You were thinking AlphaGo is much more about MCTS than about neural networks. Okay, good question. So the other hat that I wear is I have been doing a lot of work in reinforcement learning lately, and I've been leading tutorials for AnyScale, for RLlib and Ray, and doing a lot of work with Ray. And one of the things that I feel is really important is, yeah, you mentioned about AlphaGo. I believe that there are a lot of opportunities ahead for leveraging reinforcement learning in the general case, but in more constrained cases, perhaps contextual bandits or just AutoML, that area of using deep learning. And using some of this tooling for convex optimization. There's a lot of reasons for using that with respect to search and graphs and optimizing what we see in terms of graphs. And that's part of why I was doing the KG Lab thing. Was we want to try to tilt it toward using Ray as opposed to using a graph database. And then we want to infuse more things like Tune and RLlib and start doing some really serious reinforcement learning along the lines of AlphaGo, toward how can we do something interesting in search. So I'd love to talk with you more about that. Other questions? And yeah, actually, Jeff, yeah, if you join us at Metadata Day, we will have Joel Hellestein will be one of the people there, Natasha Noy. I mean, if you want to talk with people who know about this area, they will be there. Yeah, Walter had a good question. Something about Kubeflow. I'm going to use sentiment AI to detect your expression, right? Okay. Well, I'm being somewhat veiled, not entirely candid, but I have mixed feelings about Kubeflow. I do think there's a really great set of tooling coming up in terms of workflows, and workflows are the game here. I really love what Spacey has done with pipelines and having really extensible pipelines. I've been involved a lot in the Jupyter community, and there's a lot of really interesting work there. Netflix is probably a great example of that in particular. But just in general, the area of workflows, a lot of great work in open source coming out of IBM and Elira, some of these others that are very savvy about what are we doing with workflows, because at the end of the day, reproducible workflows are how we earn a living in this field, and we really need to be paying much more attention to issues of bias, issues of ethics, and those get introduced typically in early stages of workflows. And also just the feedback loops that you can do within workflows are really interesting. And it's where things like, if you go to Waterloo, there's a really great work on HoloClean using weak supervision for data preparation. And how can we incorporate both AI feedback and different methods like weak supervision, and combining that with more of the human in the loop aspects of getting these feedback loops with people and machines involved to make the workflows better and more repeatable and more accurate. So that's definitely, I don't think that Kubeflow is the end all be all. I'm glad they did what they did, but I do see a lot of work ahead in the workflows area, and that's why I was mentioning things like Biome. I'm probably way past time. Thank you, David. Thank you so much. And I will. It sounds like somebody else. Hi.
Sorry, I didn't want to leave you there. I just, without saying bye, thank you so much. I think you covered so much more. I think you could probably have a Twitch stream and keep this going 24 hours.
Oh, that'd be fun.
No, but really, that was fantastic. One of the big takeaways is that we only scratched the surface, and you have so much to offer. So now that we've gotten you to share with our audience, I hope we get you back again.
I'd love to.
Thank you so much. I'll let you get on your way, and thank you everybody for your fantastic questions. Take care, Paco. All the best.
Thanks, David. Hope this goes very well. I look forward to the rest of the conference.
Thank you.